Hello everyone. I am Romit Kawre. So, I'm working as a research fellow at MRC. I graduated from IIT Delhi with a BTech in civil engineering, and now since the past 2 years, have been working on the sediment management in the tropical waters of the Indian Ocean. So, that's what I'll discuss today. The thing is, we talk about sediments. Sediments are of very crucial when we talk about the freshwater systems or the coastal dynamics as well, but how their dynamics work, it's not clearly understood. In fact, the efficient management of these sediment holds economic, social, as well as environmental consideration. Now, when we talk about the sediment management, we are mostly focused on the two aspects, which is the sediment classification, which I will talk about later, and the sediment transport studies. Now, this sediment transport study is very much crucial in the global geochemical cycles. When we talk about the land use, the sediment erosion rates, human interventions, all of these emerge as a primary factor which influence the sediment influx into the various coastal or the freshwater systems that are there. So when we talk about the sediment management, we are mostly focused on the freshwater system and the coastal regions. So in the freshwater systems, we have the major river basins that are there. We know the Ganga and the Brahmaputra rivers. Now these carry excessive sediments when we talk about the monsoon season is there, which leads to a lot of sedimentation, especially in the Sundarban Delta region or in the Bay of Bengal region. Then there are the various reservoirs that are there. Due to the excess sedimentation, the Central Water Commission says that there is an annual reduction of 1.5% storage due to this sedimentation. This also has implications for water quality when we talk about the inland water transport and all. Apart from that, when we talk about the coastal regions, uh, there are various ports, inland water transport is also there, and the sediment management basically controls the operations of these crucial regions. It influences the navigation of efficient operations of the of shipping, navigation, and all. Apart from that, they also house various estuaries, coral reefs, mangroves, and other marine ecosystem hotspots are there. And with the advanced with the high human activities that are there in the exclusive economic zone, all of this pose a major challenge, including pollution, overfishing. Then there is the underwater radiated noise. All of this affect the coastal regions. That were these two freshwater system and coastal regions needs to be separately understood. Now, when we talk about the other aspect, that is the sediment classification. So it basically means we are trying to understand what is the seabed composed of. What are the various sediment types? What are the various layers under the water of sediment? Now, this plays a crucial role uh, when we talk about the various biotic and the abiotic aspects of the marine ecosystem. We are mostly working on the three applications. The first one is the sediment bearing pressure, which is required for the foundation design of the offshore infrastructure, like there may be various oil rigs and all, or offshore bridges and all. Then there is the benthic ecosystem assessment, which is basically understanding or basically monitoring the well-being or the quality of the life at the bottommost or near the seabed or the riverbed that is there. And then is the abiotic element detection, where we talk about the marine litter that is suspended in the sediments, or about the polymetallic nodules are there, or offshore oil and gas exploration. So all of these applications come under the sediment classification, and all of the monitoring and all is greatly affected by the texture of the sediments, how is the distribution, basically the topography of the various sediments that are there. Another major task is understanding how the sediment plays a crucial role in the dredging operations. So when we talk about the port systems or the inland waterways, dredging is constantly taken up. But what we fail to understand is how does this sediment dynamics affect the constant dredging. There, due to the various coastal dynamics, water dynamics, or other human interventions, there might be a redistribution of the sediments, which would require dredging again and again. So annual dredging might be required. Now this is time consuming, this is expensive as well, and it affects the marine ecosystem and other channel characteristics as well. We have not been able to clearly understand how the sediment dynamics plays a crucial role in these dredging operations. So what is happening now with the advent of the internet of things, the 5G technology is there, or artificial intelligence. We can have this real time data feed can be done. So say we are having judging operations, we can directly have a real time feed of understanding how it is affecting the seabed, understand how the marine ecosystem is getting affected. Similarly, with this 5G technology, we can have real time data sharing, so we can identify what are the various stakeholders that are there. There might be operators, then policymaker or the decision makers that are there. We might be able to share data, and with the rise of cloud computing, we can cloud computing, various data storages are there. We can have real time data analysis skills as well, in order to have proper monitoring or proper interpretations of the data that are being collected to make informed decisions. When we talk about data, we all know that without data we can't properly understand what is the current local situation and formulate holistic plans. So collection of data can happen through various optical sensors are there. We have acoustic sensors that are there, that can be on board the remotely operated vehicles, or the AUVs are there. Large scale modeling and simulation tools have also been developed for a large scale understanding of our vast oceans. But all of this require a significant amount of data, and as we know that the Indian Ocean lacks significant amount of data. Whenever if I talk about even bathymetry as well, the MH370 case shows that a mere 2 to 3% of the seabed is being studied for bathymetry. So Indian Ocean lacks the most basic data as well. But when we talk about data collection and all, we fail to understand what are the crucial tropical conditions. Now, the Indian Ocean is more is warmest amongst the Pacific Ocean or the other major oceans or water bodies. It contains rich biodiversity. It has mangroves, various coral reefs are there, which again needs to be properly assessed. And then the rise in human activities. It's a hub for global shipping, oil and gas, and there are various economic activities that are going on. How they affect the working of the various sensors. We have the ambient noise that is being generated. How this affect the acoustic systems. Apart from that, when we talk about acoustics, the tropical waters, the SOFA depth, which is very much crucial for the efficient underwater communication of the acoustic systems, it lies at the greater depth in the tropical waters, which leads to inefficient operations of the acoustic systems that are there. Thus, whenever the systems are being developed, we have challenges of background noise, which comes from the various biodiversity or from various economic activities that are there. Now, this leads to the problems in deployment, calibration, and maintenance. There are various constraints for the equipment and the operational cost of these acoustic sensors. And thus, whatever systems that have been mostly imported from other part of the globe, the efficiency reduces to around 60 to 70%. Now, what does it do? It makes India reliant on the Western technology rather than developing our own systems. Thus, what we are trying to understand is, for each of the applications of sediment management, we can have this 2C, to understand to share model for the data collection. So in 2C, we can understand what are the various hardware requirements, various sensors that are required for initial data collection. And then once the data is collected, we come to the to understand part. We see, due to the noise fluctuation or the medium propagation, it may instill various noise into the raw data. How we are going to filter the data, and then make it in a and then make good interpretations from the data. What are the various algorithms? So we have machine learning algorithms, various noise filtering algorithms are there. How are we going to apply them in order to interpret the specific data that we want for specific stakeholders? And then once we are able to identify and understand the data, how are we going to share this data? Do we have a common integrated platform for that? Do Is there any particular graphical user interface? We are going to understand that. And this, the UDA helps us in sensitizing the various stakeholders. So we have the outreach phase, where we reach out to the various decision makers or the policy makers, hold various crucial workshops, engage them with the various policy and the technological interventions. And finally, with the help of the user, academy, and industry partnership, we have skilling programs that are there in order to skill the future workforce which are going to take up these projects in the field. Then we integrate this with the marine special planning for better decision making. The data, the stakeholders, all must be properly visualized and then be shared between the various stakeholders. Thus, what are we looking is understanding how can we collect, how can we go on with the data collection, integrate them with the specific stakeholders, have the policy objectives, the technological interventions in order to form a holistic, integrated sediment management approach. So this is what our work has been there. With this, I'll end the discussion. Yeah, thank you, everyone.